Hi everyone, Yun here. Thank you for tuning into another video. And today I just wanted to go over more fundamentals, and this includes solving forces in plane, so 2D forces. So there are different methods of doing this. You can use geometry, you can use algebra, you can um, use components of the forces in different directions. But today I just want to focus on algebra. I have a few examples here, and we can go over the other types of ways in other videos. So I have two examples here. Actually, I have a few more, but I think I'll make this a two-part video. So this first example here, two forces, F1, F2, act on a bracket as shown in figure 1. Knowing that F1 is perpendicular to F2, this is very important. Determine the resultant R and its direction with respect to the horizontal. So we're going to use the algebraic solution. So I just zoomed in here, and you can pause the video here and attempt the question by yourself, but I'll just go right ahead and solve it. So we can just, using this diagram here, what we want is two things. We want angles. So let me just pop this here. This is 35 degrees, and we know that this is perpendicular, so this means that this angle is 55 degrees. No, 55 degrees. And if we make another drawing, R is basically the sum of the forces. If that makes it easier for you to visualize. There we go. So this is F1, this is F2, and this is R. And we have some angles here, which I'll go over later. And you should have known this formula, and if you don't, I'll just show it here. The formula to calculate R, so R is equal to, if in any triangle with any angle, is equal to R squared, is equal to F1 squared plus F2 squared minus 2 times F1 F2 cosine F1 F2. And so this formula is used for any triangle, but in this case here, this is why the information is important. F1 and F2 are perpendicular, meaning the cosine of 90 degrees is 0. So all this factor here disappears, and we're just left with this information here. So we can easily calculate R using this information. So R is simply equal to the square root of F1 squared. So F1 is equal to 900 squared plus F2, which is 600 squared. There we go. And that comes out as 1081.7 newtons. Here we go. Now, if you can see, I just hid the solutions here, but I'll show them to you afterwards. And now we want the angle between the resultant here, which imagine it's here. We want the angle between the resultant and the horizontal. Now, there's another rule called the sine rule, which basically means that in any triangle, the side divided by sine of the opposite angle. So let's imagine this is alpha, this is beta, and we know that this is 90 degrees. So that would mean that R divided by sine of 90 degrees is the same as F2 over sine of alpha. Right, so F2 is here. F2 is right over here, and the opposite angle is alpha at the top. And that is the same as F1 over sine beta. Now we're interested in the horizontal axis, so we'll be looking at finding alpha, and once we have alpha, it will be this angle here. Once we have alpha, we just need to add 55 degrees and we'll get the angle to the horizontal. So we need alpha, we have R, we have F2, and we have F1. So we're going to use a simple proportional formula or method. So, and we know that sine 90 is the same as 1. So this is going to help us. So we're going to find sine alpha. If we make it, sine alpha is simply, I'll just put it like this, sine alpha is equal to F2 times sine 90, well, that is 1, divided by R. This means that alpha is equal to sine inverse of F2, which is 600, divided by 1081.7. And this is going to give us approximately, we'll check on the calculator, sine minus 1 of 600 divided by 1081.7. This is going to give us approximately 33.7 degrees. So, like I just said here, this is alpha, and we want the angle with the horizontal. So the angle is simply equal to alpha plus 55 degrees, and this is equal to 88.7 degrees, which is what we have in the answer above. Here we go, fantastic. So hopefully you got that right. If not, you can ask anything in the comments or any clarifications. If you're finding this video useful so far, I would really appreciate it if you could leave a like and maybe subscribe, and also share the content to any of your friends if you think they'll benefit from it. But anyway, let's get back to it with the second question. So this is more or less the same type of question. We are also being told that F1 and F2 are perpendicular, but this time we want the angle with the vertical axis. So, same as here, this is perpendicular, so if this is 40 degrees, this is going to be 50 degrees. And same as before, knowing that with this formula here, we know that F1 and F2 are perpendicular, so this will become 0, so we can use this formula straight away, which will make things a lot easier and a lot quicker. So R is equal to the square root of 6 squared plus 4 squared. These are two F1 and F2, and this is going to give us 7.21 kilonewtons, which is fantastic. Now for the angle, just like before, we're going to have a bit of trigonometry. So this is the 6, this is the 4 kilonewtons, and we have R here. And the same as before with the different angles. If this is F1, this is F2, and this is R, we're going to have the same as before, where R is equal to R over sine of 90 degrees. This is 90 degrees, so this is going to be 1 again. Is the same as F1 over beta, is the same as F2 over alpha. So same again, we want the vertical, the angle with the vertical, so we're looking for alpha. If we were looking for the horizontal, then we would go ahead and look for beta. So we know R, we know F2, sine 90 is equal to 1 once again, And so let's just go ahead and solve for, we forgot the sign here, sine beta, sine alpha. So sine alpha, same as before, f2, this is sine 90, f2 times 1 over r. This means that alpha is equal to sine minus 1, sine inverse of f2, which is 4 kilonewton over 7.21. And this is going to give us an alpha equals 2. I believe this is the same answer as previous, which is sort of weird. Yes, exactly. So that's 33.7 degrees. And now we have the angle. Let's imagine the result of this here, r. And now we have this angle here, which is alpha. And now the angle between r and the vertical is simply 50 plus alpha. So let me just write that here. Is 50 degrees plus alpha, which is equal to 83.7 degrees. Perfect. So you can see here, everything is correct. And same again, if you have any questions, you can just put them in the comments and I'll try my best to reply. And that's all for this video. As I said, I have more examples which I'll post a new video about. And I hope you enjoyed this video and you found it really helpful. If you could please consider subscribing, and because I'll upload lots of videos like this. And if you have any other suggestions of video ideas covering anything in maths or civil engineering, mechanics, everything like that, just feel free to put in the comments and I will look into it for you. So there we go. Thank you very much for watching and I'll see you next time.